This is the solution to problem number 90 from homework 2.2. And we're told that a rectangle is bounded by the x-axis and the semicircle y equals the square root of 36 minus x squared. So this red semicircle is described by the equation y equals the square root of 36 minus x squared. And then we're asked to write the equation for the area A of the rectangle as a function of x. And I've shown the area of the rectangle as this shaded area here. And this rectangle will change depending on the coordinate of x, y we choose. So for example, if we choose another point, we'll get another area. And that area will vary as a function of x. So let's begin by trying to write the equation for the area of the rectangle. So area for this rectangle would be, well, we have to figure out what the length and the width are. So this distance that I've highlighted here is equal to x, right? We can see that because we have the x coordinate of the ordered pair x comma y, and x, what I've drawn, is that same distance. So the base of the rectangle will actually be 2x times its height, and its height is going to be y because we're given the y coordinate of that point. So the formula for the area of the rectangle would be 2x times y. But that's a function in terms of x and y, and we really just want a as a function of x alone. So what we can do is we can substitute in the formula for the semicircle, or the function for the semicircle, in for y. So now we'll have the area as a function of x is 2x times the square root of 36 minus x squared. And this formula will give us the area as a function of x on that semicircle. Now, to determine the domain, we have to go back to what we've learned previously. And when we have a square root, we have to be careful because if we take the square root, the value under the square root must be greater than or equal to 0. So we know that we can't take the square root of a negative number and get a real value. We can get an imaginary value, but here we need a real value, so we have to solve this inequality. And that's 36 minus x squared. Normally we'd put greater than or equal to 0, but we have to think about what x means for this particular situation. And here we know that x has to be greater than 0 because x is a length, right? For in our area equation, when we have x, we're going to have area as 2 times x times y. If x is negative, we're going to get negative area, and that doesn't make sense. So x has to be greater than 0, and we also know that the y value will also have to be greater than 0. So let me get a pen. And we know y has to be greater than 0. It can't be equal to 0. So I'm not going to actually put 36 minus x squared is greater than or equal to 0. I'm going to just put 36 minus x squared is greater than 0. So let's change that to a greater than, because the equal to doesn't make sense. And now we're going to solve this inequality. So 36 is greater than x squared. I'm going to rewrite this as x squared is less than 36. I'm going to take the square root of both sides. When I take the square root of x squared, I get the absolute value of x, and that's going to be less than the square root of 36, which is 6. And then I'm going to solve this absolute value inequality. So I'm going to have x is less than 6 and greater than negative 6. Remember, less than. But we've already said that x has to be greater than 0. So we're really going to write x is greater than 0 and less than 6. And in interval notation, we could write parentheses 0, 6, comma, parentheses.